Hi Spring fans, welcome to another installment of Spring Tips. This time we're going to take a look at the amazing MQTT technology, and we're going to do so in terms of the HiveMQ MQTT broker with my friend and fellow Java champion, Mary Grygleski. Mary is a developer advocate over at HiveMQ and a long-known, well-respected member of the Java community. And so when we started talking and we realized there was an opportunity to do this production together, to do this video together, I jumped at the chance. MQTT is one of those things that I've long since wanted to do a video on, and I just never really had the sort of time or the priority to get it done. But this was a sort of forcing function. I love messaging. I love integration. And so MQTT serves a natural use case in that space. It is a very ubiquitous protocol in the IoT and embedded firmware sort of use case space. It's ubiquitous, and it means that if you understand how to speak that protocol, you can connect all sorts of different clients together in terms of the protocols that they already speak. MQTT is not new, however. It's been around for a long time. Indeed, even the Spring integration adapter for MQTT has to be getting on closer to 10 years than not. I remember when we first added it, when we first started having conversations around it, back in like 2012 or 11 or 13, something like that. It all kind of blurs together. But suffice it to say, I was at VMware the first time, right? We have since left, spun out, formed a company called Pivotal, and then came back in, right, in that time. So that adapter has been there for a while. It's been used, loved, embraced by the community, and it grows and grows, and it gets better and better. And I've just never had a chance to cover it. People are using it, they seem to get it, but I really wanted to show people why it's so useful. Maybe it'll spark some ideas in your head. Maybe it'll inspire you to connect your systems in yet one more interesting way, using one of my all-time favorite technologies, Spring integration, which is, at the end of the day, an enterprise application integration framework. But these days, as often as not, the enterprise is no longer just services and desktops. It's all sorts of other devices proliferated across all sorts of different networks. So this is a very useful thing to know indeed. Let's get right into it. First up, Mary will take us on a tour of the protocol and the technology. And then I will introduce us to how to use Spring integration and MQTT and HiveMQ together in a Spring Boot application and with Spring integration and Spring native. Stay tuned.
So we're here to talk about MQTT. MQTT is a protocol that's designed specifically for IoT purposes. It can be used for non-IoT scenarios too. Nothing is preventing it from doing so. But the core, the primary reason for it to exist is really to serve all of IoT's messaging in between devices for machine-to-machine types of communication, and that's what it is best at. Let's take a look too. But first, we will look at the IoT stack. This way, we understand how MQTT fits into this picture, into the IoT landscape as of now, right? As of today, as such, things change so fast, So from 30,000 feet, let's try to understand the IoT stack. When I first started working at HiveMQ, I started looking more into IoT because in my mind, I was always thinking of IoT. They are small device-to-device communications, maybe machine-to-machine types of communication, data transmission. But as I'm learning more too, I realize, well, the AI, the data science folks and everybody is interested in it. If you go to any city and looking up their meetup groups for IoT, it's always kind of all things. So it's essentially, to me, in my mind now, I've expanded that understanding, and I did some research, and then also to come to understand that there's a different stack that's kind of abstracting out of these things and talk about it. It's by no means the only way of describing it, but I believe that that's a fairly accurate way to describe it as of today, as of the Industrial Revolution version 4.0. So the Industry 4.0, that's where we are at right now. But let's take a look. So I kind of go from the top first, IoT stack. I call it like solutions layer, and that's really can be subcategorized into three other categories, right, or groups, essentially. Not limiting to these three groups are consumer. So, for example, you have wearables, right? You have mobility type of devices, entertainment, things in your refrigerator. You can actually install some appliance or kind of small sensors to sense that you are running low on milk, for example. Things like that. Really, we're not limited by anything. I mean, our minds are our limitations. So we need to open up and kind of open up to all of the possibility that we can basically utilize IoT technology to enable it. So that's consumer. So lifestyle thing, all these things. So we know what that is, right? The lighting in your house, it's the motion sensor, something like that. And so that's consumer. Now on the enterprise level, more of the business side, then we see there are business operations, ERP, marketing. You can always kind of make use of some kind of devices and transmit those data for your analysis, for your business, operational purposes or analytical things, however way you need it, right? So that's enterprise. Now, bring it up to another level is really the industrial kind of usages. What I talk about, Industry 4.0, that's the, in the grand scheme of things, this is, we're into the 4.0 version of the Industrial Revolution. At this point, we're kind of talking about all of the devices, all of the machines, anything that's connected to the network, to the internet. They would be able to communicate with one another. There's a large degree of interoperability between all of these different systems. Very exciting. And so on the industrial level too, there's also manufacturing, right? That's kind of first and foremost. There are factory automation, small devices that are installed into a factory that can send out different signals. So it'd be picked up by some other devices to do certain things in a workflow type of processes, right? And then there are automotive industry, connected cars, logistics, right? Shipping industry, they're making use of that. And think of like a UPS delivery guy, and they could be carrying some devices that are doing some kind of tracking as they are doing their work. And construction, right? Oil and gas and pipeline, all those things. So now we understand the solutions kind of layer that makes use of multiple technologies that kind of comprises all of these IoT kind of enablement underneath. So let's kind of take a look then. We further kind of go down the stack. There's a cognitive platform too that are more interactions like spoken, gestures, you name it. Like I said, there's speed, right? All these things, temperature, sensor, all these things. And well, they can be cognitive too. So the artificial intelligence comes into play, voice recognition, all of these are utilizing data that's generated by capturing data from IoT enabled devices. Then there's also analytics platform that these are really like they're providing services of analyzing the data that's been collected, reports, events, stream processing, machine learning, all of these. Now, but let's kind of go back down into the bottom of the stack, or as I kind of look at it, right? This is really the physical layer. These are the devices, the actual devices that can collect data. Smart devices, sensors, actuators, embedded devices, all kinds, right? You can name it to your wearables, right? And so those are devices. In order for them to be able to transmit data, they need to be able to capture the data, needs to be able to sense, right? And there's any movement, any kind of things they are measuring, they needs to send out data in the form of signals, right? Essentially, these are signals. So we need protocols to handle that. So on the communication protocol side, and that's where MQTT fits in. Now, as such, too, don't kind of get all mixed up with the OSI layer. Of course, the networking, OSI, that's kind of been the standard of networking, the 7 layers. So MQTT actually sits on the application layer, which is like the 7th layer of the OSI model. But within the IoT stack, it is on the communication protocol side. So I've kind of like loosely kind of group all of these OSI kind of communication networking protocol onto the communication protocol of the IoT stack. So if you look into it, then there's, besides MQTT to doing IoT work, you can actually use HTTP too. Nobody stops you for doing it, but is it designed for IoT? I don't think so. Not ideal, right? Kind of, we know too, it's stateless and it doesn't do message retention, all of these things. So anyway, that's kind of outside the scope of this discussion, but we're here to talk about MQTT and why it is, right, the choice of protocol protocol for device-to-device, machine-to-machine IoT communication. But anyway, so there's also CoAP, and these are constrained application protocol. That's also good for IoT scenario, although it's a bit less kind of emphasis on reliability because of it being like doing work on the UDP layer, so not as reliable as TCP for MQTT. So. And then there are also, if we go down the list here, in an example, AMQP, which originated from the financial industry, right, and now kind of becoming a part of the OASIS specification. So AMQP is RapidMQ, for example, is also like a protocol that's built on the AMQP protocol. So you can use that for doing IoT communication too. And then DDS is Data Distribution Service. These are like as such, right? The name means like really kind of designed, catered more for IoT data, kind of carrying those things. So, and then there's also XMPP. XMPP is XML based, and they're a bit older too, and they not way too old, but the kind of older protocol that's actually ideal more for instant messaging. For example, like I think the Google messaging, they uses that too. So, and then there are other things, right? Like the IP version 4, right? V4, IPv6, the 6LoWPAN. These are for lower kind of powered situation, right? For IPv6, and then Bluetooth. Now, Bluetooth has its own stack too, by the way. Something too I'm learning as I'm picking up all of these networking specifics, and I didn't know Bluetooth has its own, and it's also a mixed use of radio waves, and it's kind of different, and it has its own stack within it. So, but it's kind of falls into the communication protocols too. And then there's also GSM, Modbus, BACnet, all of these other things too that belongs to the communication protocols layer, and of which MQTT is a primary one for IoT kind of usage scenario. Now, if we can go up one more, it's basically, MQTT cannot function on its own. It's just a specification of protocol. Something needs to drive it. So in that case, like HiveMQ, right, comes in, is the IoT messaging middleware that makes use of MQTT, the protocol, and provide services for enterprise kind of usages for messaging as a messaging middleware. It does its job really well, the broker. So that's more belongs to the core platforms, kind of really infrastructural type of services in that sense. Then there are also protocol gateways, data aggregation, data storage and filter. These are more of core infrastructural services type of platform. So that's where MQTT and the HiveMQ product set kind of fits inside this IoT stack. So now then, let me then take a look, start kind of going through, is looking at MQTT now. I spent enough time talking about that. So what is MQTT? It is a standard binary publish subscribe messaging protocol that's designed for fast and reliable data transport between devices, and especially under very constrained type of conditions. So constrained conditions are such as like in a situation in which the network is not reliable. And in fact, I'd say networking itself is never really reliable. As developers, we like to think we can code where we have the whole world under our hands, but no, guess what? The more distributed our systems are these days, what other systems are not, being, running on the internet. Everybody is using the internet. But the thing is too, we cannot rely on the internet being reliable. And also the fact that there will be latency too. So in situation in which we can expect the network latency to be high, that type of situations, you probably want to consider using MQTT. In also like network, if you have very limited bandwidth, limited battery, your memory capacity in your devices, those are kind of perfect conditions for using the MQTT protocol. And I will explain a little more as I kind of go into the next set of slides and talking about it. So it's built on top of TCP/IP in the stack, right? And so TCP/IP, as you know, it's more reliable because of the acknowledgement too. So I will kind of bring up to the mechanism that MQTT uses for guaranteeing message delivery, and it's really ideal for the Internet of Things. So here too, in my slide too, I have an example of just very simple to describe. Okay, HiveMQ, it provides the broker. That's kind of like the core, the crux of the product set is the broker, or any kind of MQTT scenario. You need this broker as the server, the centerpiece. Think of it like a post office, and you are are the one to send messages, right? You send letters. You don't go and deliver your mail to each and every of your client. That would take forever. If you have hundreds of clients and customers and all that. So what you do is you go through a post office. So in this case, I'm the publisher. I'm the one, and I need to send out a bunch of messages. And I kind of tell the broker, hey, these are all of the messages I have. And the way the mechanism it uses is that it's not about knowing who you are sending to. There's no physical address, right? To say, okay, this message I want to send to customer A and then that one to customer B. No, it's not like that. It's more like, well, I have all of these messages that I need to send out to customers. So I will label them and call them a topic, right? So I have the topic associated with each message. So it's up to the consumer side, right? The receiving side, that if they are interested in it, they will have to subscribe to the topic for the messages that will be published there. So essentially, that's what it is. And so in this particular case, I have a speedometer that's publishing all of this speed, and I publish all of these data, the data of the speed data to the broker and label it accordingly. Let's call it like speed in this particular example. So then in this case too is that it will be up to the broker to distribute the message when the messages are available to those who have subscribed to the topic speed. So in this particular example will be like a mobile device is subscribed to it. So when speed gets published, that mobile device will receive it. And so is the other subscriber, a backend server, for example. So, and now then, before we kind of delve in too much yet, let's kind of look into the history of MQTT. I think it's kind of worth mentioning a little bit too. So back in 1999, there is a IBM researcher. His name is Andy Clark, and he's still there. In fact, at the UK lab, right, in Hursley, United Kingdom. So he was working on a project for a customer, and he and another partner of his, Arlen Nipper, that's not an IBMer, but nonetheless, they worked together on this project, and then they had to gather data from like an oil pipeline, and it's traveling through the pipeline, and it's under very constrained environment. They're communicating with satellite. They couldn't find anything that could help them in terms of a protocol level to help with the transport of the data. So they came up with the idea of calling it MQTT, which stands for message queue, which we know that comes from IBM, the message queue capability, the MOM series, right? So MQ, they use MQ and then add the TT, telemetry transport. So they name it MQTT. So that was born in 1999. Now, over time too, with the rise of the internet, all of the Internet of Things, all of these, then folks kind of take it and decide that this is a good protocol. We can extend it further, so to speak, adjust the need for IoT type of usage scenario. So in 2010, MQTT 3.1 got opened up as a royalty-free protocol. So essentially, it's just open protocol for anybody to use it. And then obviously then there are like vendors and projects that started implementing it. And in 2012, the Eclipse project, Mosquito 1.0 got released. And soon after that, HiveMQ 1.3 got released. And by the way, HiveMQ then was born in about 2012 kind of time frame by actually a group of students at the time who are now the founders of HiveMQ. So in 2013, they released 1.3. And then soon after that too is basically the industry realized that we need a technical committee around it to help to govern this specification. So Oasis was actually chosen as the kind of organization behind this, and there's actually a technical committee that's got formed in 2013, of which HiveMQ is to this day still very actively engaged in doing the specification of MQTT. And then 2014, that's when another major release, kind of a minor release, 3.1.1. Nonetheless, it becomes kind of almost like de facto kind of version that most vendors have. In fact, if they're a MQTT broker, they would be implementing MQTT 3.1.1, and that's more of the majority of vendors of this day. But we're expecting more for MQTT 5, which actually got released in 2018, and then HiveMQ 2 soon come out with the HiveMQ 4 version 4, and that has MQTT 5 support. The good thing about MQTT 5 is that it's more catered for the cloud native age that we live in now, more addressing the needs for scalability, resiliency, things of that nature that needs to happen, right? That needs to have that capability for cloud operating in the cloud environment. So. And just a really quick note, into the MQTT technical committee. To this day, there are 9 obligated members, of which HiveMQ is a member. And then, as I mentioned, two of the 3 founders, Christian Getz, who's the CEO, and then Dominic Obermeyer, the CTO. They're really passionate people. They are still guiding this committee along with the other companies here that I've listed: ThinkStream, IBM, 9Nevix, Cisco, Solace, Microsoft, EMQ, and Software AG. So alongside with HiveMQ, they are the ones that are leading the effort of this technical committee. And now then let's take a look into the MQTT overview. So again, it is an IoT messaging protocol, and it has 3 quality of service levels. Now, QoS, as we all know, is quality of service is a mechanism to guide message delivery and guarantee the delivery, right? So then data is not lost. As we know, in any kind of asynchronous type of communication scenario, it is very important to guarantee the delivery of messages, because you don't want to just send a message and not knowing where it goes. Did the recipient get it, and all that kind of stuff. So we have QoS mechanism built into the MQTT protocol itself, and then there's also a concept of retained messages that I'll get to it, and also too, because of the broker, it actually offers this stateful persistent sessions kind of capability too, because of this kind of need, for the broker to also help with, maintaining state of the data. And then there's and essentially too, MQTT is a binary protocol, and it has very small overhead. So that's the kind of advantageous for it to be chosen as the standard protocol for IoT, under very limited constrained type of operating environment. So okay, so now get a bit into the detail of this MQTT 3, essentially MQTT 3.1.1 that we're talking about. So first of all, publish, subscribe, we'll talk a bit too. In any kind of publish, subscribe type of model, is actually the very basic thing that will happen is that you will need some sort of a server. So in an MQTT world is the broker. So the broker is responsible for many things. In fact, it's kind of like the crux of this the whole operation, because you need that. If it's not there, nothing can happen, right? So it's a centerpiece. So anything else, right? If you are publishing or subscribing, you are considered a client. So you're MQTT client. So MQTT broker, then there are essentially 3 commands that are basic, right? That needs to happen for any type of MQTT communication to occur. So first of all is the command called connect, right? First of all, you need to make a connection first from the client to the broker, and the broker needs to send back an acknowledgement to indicate it receives the packet. And then once the connection is established, then you can subscribe. Clients can then subscribe. You can have the subscribing side, and then the publishing side can send publish. So likewise, both ways too. You send subscribe, you will be hearing back from the broker, getting back an acknowledgement packet, and then on the publishing side, same thing, you get an acknowledgement back, and that's kind of like the basic kind of operating mechanism. But then don't look at it like so simple. You can actually be very, very complicated, and that's why we have all of these kind of discussion, right, about all the features that comes with it, right? And then so don't be fooled. Sometimes things are simplified in the design, but it's actually really good. But it also handles a lot of complicated usage scenario. So likewise, too, on the right-hand side here, I'm using another example here. Much like the speedometer, I'm using a temperature sensor. I publish the data whenever there's a temperature kind of changes. I publish the data to the broker, and then it's up to the subscribing client who are interested in the data will subscribe to the topic, and they will be receiving any kind of data that's sent to the broker, unless you set some sort of parameters. But most of the time, if you just connect, by default to once the data arrives, you will be getting it if you're a subscriber to it. And let's kind of dive a little deeper further yet, is to take a look into the packet itself. So let's take a look into the connect, right? That's kind of the basic. Any kind of operations, you do need to make a connect regardless of whether you are the publishing side or the subscribing side. So in the connect packet, as you can see, there's a client ID. That's kind of unique identifier within the session that this is your client, right? Identifier. And it indicates if it's a clean session or not. And then a bunch of like optional parameters such as like username, password, last will that includes like last will topic, last will QoS, the quality of service level, and last will message and last will retain. All of these are kind of optional parameters. And then there's keep alive is basically saying that, okay, if I don't hear back, how long should I, wait for the acknowledgement back from the broker? So in this particular example, will be like a 60 seconds. Then if it doesn't hear of anything, then it's basically will resend the packet over to the broker too. And so now, if the broker respond back, gets everything, and the broker is supposed to send back an acknowledgement, so it comes back and basically says, okay, session present is true, and a return code of 0 in this case. Now, let's then talk a bit about the will. So basically, will, right, is much like people. We don't live forever, right? The messages, the clients may get dropped for whatever reason. So now, in order to guarantee that your receiving end won't be disappointed, that you are not like suddenly disappear. So I set myself up, right? It's up to the client itself. You have to set up this, configure it, so then the broker will know. So basically, I define my will. It's also called last will and testament. So the broker will send this message if this client dies, right? And it is a real push, so it's useful. The usage of such is basically implement some kind of on-off kind of mechanism in a safe way. So let's say, if you do an on, and then if your client goes away, but you actually needs to turn off, maybe like a nuclear plant, right? You need to turn off some switches and things like that. It's absolutely important. So then if somehow the client dies and cannot send the offer, you have to have some ways telling the broker, okay, a broker knows that, okay, client dies, let me see, kind of last will messages, I will make sure that it gets kind of sent over properly to whoever is subscribing to it, things like that. So basically, yes, so again, messages is sent only to those who subscribe to the topic. So if you take a look too into the packet, then you can see, right, earlier on with the connect, all of these other kind of parameters like last will topic, you need to specify the topic, the quality of service level, and also the message that you want to send should it, die in the case of failure, all of that kind of stuff. And it will be a push message from the broker to all the subscribers that have subscribed to this particular topic. And again, most likely too, you also want to have more authentication. So you would want to enable username and password too. Now, let me take a look then in terms of packet. We look into the publish subscribe on a conceptual level, but also then take a look into the packet level. So for any kind of publish, right, as you can see, a publish packet will contain the packet ID, but you also will notice that it will actually, packet IDs would not be required, and it only be set it to 0 if your quality of service is 0. The reason is that, which I will kind of disclose in a little bit in the next few slides, is about talking about QoS level 0. But essentially, it's a fire and forget level of guaranteeing message delivery, right? So if you don't really care, let's say I publish in client, I don't really care so much about hearing back whether you get it or not. I just want to send it to you. You do whatever, even if it doesn't arrive. I'm not concerned. So in that case, there's no need to set the packet ID, but you do need to kind of specify the topic name, right? And also the QoS level for this publish to have too. So if it's 0, then the packet ID would be 0. But if it's one value other than 0, which is like 1 or 2, which are like 1 or 2, right? Then you do need to set the packet ID. And then the retain flag, is also an optional kind of flag, whether you want to retain the messages or not. And then the payload itself, the actual messages you're trying to send over to the subscriber, and whether it's a duplicate flag or not, and those things. Okay, and then on the subscribing side too, this is also interesting, is that I subscribe to it. I have a packet ID. It's basically, within the same packet, I can have multiple topic subscription too within the same packet. So it kind of makes it quite efficient. So if I'm a subscriber, I want to subscribe to multiple topics, I can essentially use the same packet to do it. And you can have a number of topics that you are subscribing to within the same packet too. So. Now, the concept of retained message. So it's basically retained messages are last known good value. So basically, too, is what has happened is that on the broker side, right, if it's gets the message from the publisher, the publishing client, and if it indicates please retain, this is a retained message, that means the broker won't just kind of wipe it out or get it off the system, whatever, but they will retain it. And so the reason for that is that, and it's also a capability that's to be decided by the client, the sending client too. So if the client decides the message is to be retained, then basically it indicates that if future clients are subscribing to this topic that I have and that I'm publishing to, then please, broker, please retain my last message and send that particular message over to any kind of future clients. So the plus side of this is that it does save time too, because it just means that future clients subscribing to this topic and there's new data coming in, and it's basically there's no need to actually kind of look it up again. It's basically I already have a good value, it's retained, right? So I get sent over to whoever is coming to after this topic. So there's also reason for that is for performance, primarily kind of for performance purpose. Now you may say that, well, it doesn't take too long. Yes, it is true. Each message doesn't take too long, but we are talking about in any kind of, say, an industrial type of scenario of usage, right? Any kind of commercial enterprise usages, you could have many, right, messages that are being sent, right, all the time by sensors, by all of these things. And so every little bit will count, as kind of delay, if you add another nanosecond to it or something. So we want to make sure that time is actually very, extremely efficient. You don't waste any time for it. So now, let's get into the quality of service. So as I talk about, there are 3 levels of quality of service. QoS 0, as I mentioned, is a fire and forget type of the level. It means that at most is a once delivery, and also from the publishing side, I do not worry about getting any acknowledgement. So there's no need for the broker to send back. Even if you send it back to me, I would toss it. I don't really worry about it. So that's QoS 0. It's very fast, but it doesn't guarantee. It's a best effort delivery guarantee, essentially. And then there's also then QoS 1. This one means at least once delivery. And as you can see too, it's basically, it's a bit efficient in that sense. However, it doesn't guarantee the messages won't be delivered more than once. So in other words, you can have duplicate messages. Now, there's also QoS 2. If you wanted a bit more kind of guaranteeing the delivery is exactly once and there's no duplicate, you want to use QoS 2. But as you can see in this diagram, it takes kind of 2 pairs of kind of sending and receiving. It's kind of like the handshake. It's a bit kind of more elaborate, right? You need another round trip essentially to guarantee that it's only once that it gets delivered. So let's kind of delve into each one of them. Quality of service 0. So in a published kind of scenario, right, as you can see, packet ID would be 0 because I don't really worry about receiving anything back. There's no need for it. So no need to identify. I just send it. And I indicate my QoS is 0 in this case. For example, I don't want to retain the messages and payload. This is what it is. Take it is sort of kind of, this is like one kind of time data get published. I just want to send it over, right, that I collected from my sensor, send it over to the broker, and that's what it is. So it's very fast, simple, easy. Now going to QoS 1 then, again, this is like a pair of publish and then a publish acknowledgement from the broker. So as you can see in the packet level, the QoS, the difference in here is that the QoS level has to be 1, right? So you do need to indicate your packet ID. So then if the broker gets it, then they will send back a packet that indicates, okay, I acknowledge it and this is the packet ID. So then the publishing side knows that, okay, you got it, the broker got it, so I don't need to worry about it. Now, here's the thing too, is that with this particular level is that what if, right, I publish and then the keep alive, actually here it doesn't, this example doesn't have to keep alive, but let's say it times out. So the broker never got it, So what happened is that then my publishing side would say, well, I never got back the packet from the broker. So in this case, let me resend it. So in this case too, you also would want to then send a dup flag to it, indicating it is a duplicate messages. Now, you can actually, by the time you send it over to the broker could be already receive the original packet of data. So in that case, it takes the first set and sends back an acknowledgement, but well, too late, on my publishing side, I also send another duplicate messages. In this case, the broker will get it and then receive it and also send back another acknowledgement too. Now that would be all okay, and that's what the purpose of QoS1 is that in some cases, if you're expecting some data and you really don't worry so much in some kind of, let's say, accumulative kind of data kind of receiving side, you can have duplicate messages being received, for the same thing or something. And if you don't worry so much about it, it's maybe used for plotting a graph or something, and you can take care of if it's got received twice and it's for the same time, whatever, you would drop it on your application kind of client side. So that would be okay. So the nice thing about this is that is a little faster, right, than the next QoS level 2 that I'll be talking about. But that's the thing, is that you can allow for more than once delivery, and at least once, and that's what it is. So that's what it is. And so now let's go to the QoS2. Now, as you can see, it's a little bit more clunky, so to speak, right? You need the publish, and then okay, let's take a look, right? Publish QoS2. The first packet here, I'm QoS2, and then let's say, first time, let's say all goes well, the broker receives it within the timeout period and sends back an acknowledgement also within the timeout period. So I send it back to the sending client and have the packet ID. So I notice it, right? The publishing client got it and said, okay, all good, you receive it. Let me now send you another packet to indicate to you that, okay, I receive your first acknowledgement. So it's kind of like handshake, kind of a prolonged process. But what this does is really essentially help this message to prevent it from being distributed, like, again, over to the broker. And so by doing that, by sending another pub rel, you basically would say, okay, I'm sending you another acknowledgement, knowing that, just know that I got your acknowledgement. And then in this case, the broker would say, okay, all set, I know that you got it, so all good. I'm not going to publish it twice. I'm not going to deliver it more than once. And so it kind of helps in the preventing messages from being delivered more than once. I just want exactly once. So, but as you can see, the drawback is that it takes a little bit more time, right? Any kind of movement will increase your time of delivery, the actual delivery. Okay, so a quick thing then, let's take a look into where is then MQTT4, right? There's MQTT5, so just a little kind of nerd trivia, so to speak, right? I like that stuff, right? It's like, whoa, where is 4? So basically, on the packet level in the connect message, the detail, as you can see over here, there's a version that's in one of the field. So for MQTT 3.1.1, they actually use version 4. Like they probably decide, okay, version 3.1 of MQTT is 3, but let's say 3.1.1 is a minor release, but will indicate as 4. So whatever is written cannot be changed anymore, so they retain the 4. Now, then MQTT, the next version comes along, and they were, in this particular case, to connect this version will have to indicate is 5, so they have to up it to 5. But they thought, well, if we name it MQTT4, it's kind of not matching, right? It is going to create like confusion. So they just said, okay, whatever it is, MQTT 3.1.1, just take the 4, and then MQTT5 will get the 5, and so we name it 5. So then kind of better match up with the connect version field too, with the actual versioning that's kind of published to the outside world. So that's what it is. It's just a small little trivia piece of information. And now let's take a look at MQTT5. And so MQTT5, now this I will go a little bit faster in here because there are a lot more actually details and it's beyond the scope of this particular session. Just want to give you a taste of it, right? So MQTT5 is the successor of MQTT 3.1.1 and is non-backward compatible. And its first public release was in January of 2018, and the official release was in March of the year after, like in March of 2019. Many new features, and is essentially, to sum up, is clarifications of the 3.1.1 spec, as well as adding in the cloud native capability, as I mentioned earlier too. So Now, the goals of MQTT5 are enhancements for scalability and large-scale systems and improved error reporting. And we want to also formalize some common patterns, including capability discovery and request response pattern. Now, mind you, that's not the same as the HTTP request response. And there are also extensibility mechanisms that includes like user properties. You can basically have more metadata that's being sent, right? So kind of increase a bit of the control for the users too. And then performance improvements and support for small clients too. So these are kind of more catered for the cloud native age that we live in now. And some key new features. So session and message expiry. So it's an optional part of the connect message, and it's basically session expiry interval in seconds. And the broker expires session after the given interval as soon as the client disconnects too. So it's given the broker a bit more control too. Once I kind of client disconnect, I basically can expire the session too. And it's an optional part of the published message and applies to online and queued messages too. So that's kind of one feature, gives you more control. And the other thing is with user properties, as I mentioned, you can have user-defined metadata in the headers too, and can be part of most MQTT packets for the connect, pub, and sub packets. That's UTF-8 encoded strings, and you can have an unlimited number of user properties can be added to your metadata headers too. And then there's also another interesting features. In this case, is deal with shared subscription. So basically, too, this feature is nice because it enables for scaling out the backend subscribers. So it's really like perfect for a cloud native type of scenario of usage, right? So client load balancing, multiple clients share the same subscription, and is supported by HiveMQ for MQTT 3.1 and MQTT 3.1.1. And so essentially, HiveMQ is pretty high functioning. This feature was only introduced to MQTT 5, and HiveMQ already introduced it within the HiveMQ product set before before MQTT 5 came into being too. So essentially too, HiveMQ has kind of guided the committee to also incorporate this feature and make it official in the MQTT 5 spec. So, and it's again, upscaling, downscaling of clients at runtime is really perfect for cloud native scenarios for Kubernetes and clusters and all of these things. So it's an optional feature, not all vendors support it too. So this is a picture of describing the share subscription. So it's like your broker, you are having multiple topics, and the topics are being shared by multiple clients, the same topic being, the share subscription for a group of clients that can actually subscribe using the same subscription. So. Okay, and now then the request response, as I mentioned too about request response, is not the same as HTTP protocol of synchronous kind of client-based protocols like HTTP. So it's actually the request response pattern more catered for the business on an abstract level request response. So it's basically requests as well as responses are at least like topics and can have more than one or no subscriber in MQTT as well. So the client must subscribe to a response topic prior to sending the data too. So that's kind of important, because then what it is doing is trying to build out these correlation data header. So then you can kind of correlate who are the subscribers with this request. So kind of more kind of useful for things on a business kind of architecture kind of level too. So that's what essentially this is. So just not to be confused with the technical kind of protocol level of request response. So as you can see in here, this is a diagram that describes it, and the application, the client would have to subscribe to the topic for these to happen too. So. Okay, so just to sum up to why is MQTT kind of good, right? I kind of quickly gone over that. I might be talking for a bit too long now, but every message works as a discrete chunk of data, is opaque to the broker, and the control packet structure of MQTT is actually very small. It's made up of a fixed header, a variable header, and the payload. So the fixed header is actually very tiny. It's only 2 bytes. So it's very small, and up to 12 bytes of additional variable header can be added, right? This variable size and also it is present only when needed. So if you don't need it, there's no need for the variable headers. So you can tell, it really is efficient. It makes the delivery a lot more kind of efficient. And also, too, I wanted to quickly point out, too, is data agnostic. You can use, supports all kinds of data, images, text, in any encoding format, encrypted data, binary data, all of these things. And continuous session awareness, as I already mentioned, there are persistent sessions, different quality of services guaranteeing the delivery, retained messages, and a normal message with the retained flag will be stored and sent to new subscribers to these topics. And all of these things are already gone over. So it's really helpful, right? In a nutshell, it's actually more complicated than it looks in here, but we make it very easy to understand in this case. So all of these things, you don't have to worry about the nitty-gritty stuff. The broker will take care of things for you based on the protocol specification. So you don't have to worry about messages being dropped. And use cases for MQTT, right? And as I already mentioned in the very first slide, IoT, industrial IoT, Industry 4.0, all of these things are your automotive industry, logistics, manufacturing, energy, list goes on. Consumers level our smart home lifestyle, all these things. And you can integrate with other frameworks. And that's what we want to talk about for the Spring Boot runtime with through Spring integration. You can get fetch MQTT data too. So other MQTT brokers we can also integrate with. You can build a pipeline, talk to another broker, for example, the Eclipse Mosquito, and streaming platforms like Apache Kafka, you can connect to that and have MQTT kind of be the front end in your flow pipeline, collects all the data from your devices and basically kind of sends it over to Kafka for enterprise kind of heavier duty processing for an enterprise organization. So we want to be able to achieve IoT scale too. Essentially, we're talking about in the billions kind of level of publishes per minute, topic subscriptions, and connected devices. So it's really kind of a really perfect protocol for doing IoT type of application. So yeah, so thank you.
We needed an instance of an MQTT broker to which to connect in order to do our work. So we use HiveMQ, which is, as Mary just explained, a very powerful, world-class MQTT broker implementation. And there's a convenient Docker image that we can use out of the box just to make this even easier to get going. So I'll just paste that command and hit enter, and that'll start up a Docker instance that we can then use to write our code today. We'll go to my second favorite place on the internet, obviously, start.spring.io. And here, we're going to build an application. We're just going to call this MQTT because, why not? We're going to use Spring Native. We're going to use Spring Integration. We'll use Lumbuck, and we'll use the reactive web support. All right, let's kick that off. We're going to hit Generate and open this up in our IDE. All right, we've got a brand new project. We need to add some dependencies that we couldn't add from the initializer, namely the Spring Integration support for MQTT. So I'll say Spring Integration MQTT, or Spring Framework Integration, not Spring Boot. And that's it. We're good. Let's get going. So first things first, we're going to build an application that acts as both a producer and a consumer. So I'll create one bean that we need in common across both the producer and the consumer, namely the client connection factory, right? The MQTT PAHO client factory. Okay, var factory equals new default MQTT PAHO client factory. And then we need some options that dictate how we connect to it. Okay, so connect options. And the options include, among other things, the server URL. So we'll say new string, and we're going to point in, and by the way, this is one of those things where you reasonably should and could excise it to a property file. In fact, let's just do that. So HiveMQ.host, or better yet, HiveMQ.uri, TCP localhost 1884. And while we're at it, let's specify a topic to which we're going to connect. We're going to call that Bootiful. Okay. And this is one of those things, of course, it's reasonably going to change from one environment to another. So you keep those in property files. So I'll say at value. Okay. Good, string, host, and we'll just put that there. All right, good. We want the factory to use the options, so we'll say set connect options, and then we're going to return the factory. And that's it. That's how you connect to a Hive broker. We're going to create two flows. One's an inbound flow and one's an outbound flow. In the world of enterprise application integration, inbound flows are handled by inbound channel adapters that process the message and send the message into the Spring code where we can process it. Outbound adapters take Spring integration code and turn it into external events in the real world. So let's do the outbound flow first. So configuration, out configuration, just to keep it very simple and symmetrical. What we're going to do is we're going to arrange it so that when somebody makes a request at an HTTP endpoint, we can then send a message into a channel, which will then get sent out to our MQTT broker, where it will be delivered to a consumer, all consumers, including our very own code base. Now, naturally, these two things would normally be sort of split into separate modules, right? It makes no sense for the same Java program to act as both the producer and the consumer of the same data. But yeah, maybe you could do that. Maybe you just want to make sure the message gets routed and is stored durably somewhere before you start trying to process it. That could work, I guess. But typically, these are going to be producer and consumer, separate modules. That's okay. I am only doing it in the same code base for convenience. And again, the only redundancy that you have to specify across those two is this MQTT PAHO client factory. So just take the client factory and each configuration class, stick one in a separate jar, and there you've got a separate standalone producer and consumer. Okay, so in order for this to work, we need an HTTP endpoint. So I'll create a router function, a functional reactive router function, something that we covered way back. One of the very first Spring Tips videos we did when the API looked very different. We're going to create an endpoint here so that when somebody goes to the send endpoint with a name, it'll trigger a request, which will get handled by this handler function. And obviously, this is not REST. It's the minimum I could do to make this workable so we can see it happening, but nothing particularly special. Okay, so the body has to be, nothing actually. We can just do .ok.build, okay? And what we want is to send a message into the message channel, which will then get forwarded to the outbound channel adapter. So message channel out, and we're going to create a message builder with payload. Hello HiveMQ. Okay. And name. Okay. Now the question then is, what is the name? Well, name is the request path variable. So name, right? Because it says send curly bracket name curly bracket. So, okay, there's our message, and we want to send that into the channel adapter. So we'll say out.send message, and voila. Okay, good. Replace it with a lambda. All right, there we go. There's our outbound, there's the thing that kicks off the whole event flow. The next thing we need, of course, is that message channel. We just used it after all. It needs to exist. We're going to call this one out. And we're just going to create a message channel, direct.get. Good. And then finally, when it goes into that message channel, remember, the message channel is kind of like a Java util queue through which messages will flow. It's going to pop out the other end, and something needs to pick up that message and do something with it. That's the job of the outbound channel adapter, right? So we're going to create an adapter, a message handler. So it's called MQTT PAHO message handler. Okay, so outbound adapter, and var mh equals new MQTT PAHO message handler, and we're going to send it. We're going to give it a producer name, right? And we're going to inject the MQTT client factory. Alrighty. Return mh, but only after we've set the default topic. So that'll be yet another property that we're going to inject. Okay, HiveMQ.topic, string topic. Good. All right. Good. So there's that. Now everything is ready to be wired together, but we actually need to do the wiring, and that happens in an integration flow. So here we're going to have a outbound flow, and the flow is going to take messages from that message channel out and then send them to the MQTT PAHO message handler. Okay. So we'll say outbound adapter dot get. Alrighty, good. So there's our entire flow. That's not hard. That's not very difficult. We're just taking the data that comes out of this thing and forwarding it onto this thing, which will then forward it on to the topic and the host import implied by the configuration of the MQTT PAHO message handler in conjunction with MQTT PAHO client factory. That's outbound, okay? Now, I want to be able to see the messages, obviously. I want to see what happens, so we need a inbound configuration, right? To then consume the message that gets sent to the broker. Here, the source of the message isn't going to be something that we manually insert into the queue, into the channel. It's going to be messages that we use the adapter to perceive as being in the broker. So MQTT PAHO message-driven channel adapter, inbound adapter, and we need the topic. So HiveMQ.topic, string topic, and we need the MQTT PAHO client factory. And then we need to actually configure the bean. So return new MQTT. And here it's a consumer. These are arbitrary names, by the way. The client ID, you can specify whatever you like there. We need the factory. And we need the topic. And that's the whole thing there. And of course, we need an integration flow. So integration flow, inbound flow, turn integration flows dot from, and we'll use this adapter. Okay. And we're going to handle it by just logging the result, I suppose. That's no big deal, right? We can do that. Okay. Dot get. So, new message. Payload. Headers dot for each KV. V. All right, there's this. Good. Okay, everything looks to be in order. Let's just do a quick run through to make sure. Local host. Okay, everything seems to be in order now. Let's try it again. Okay, there we go. So it's up and running. If we go to our command line, here, curl, HTTP, localhost, 8080, send world. And there we go. As soon as we do that, we get this message. New message, hello HiveMQ and world. And we got these headers that indicate that the message was consumed. These are things that are added by the Spring integration flow that you can use for correlation and so on later on. All right, that's a very simple hello world introduction to HiveMQ. We could stop here, but I do want to show one more thing. You see, one of the benefits of using HiveMQ and MQTT is that the protocol is ubiquitous in the IoT and embedded space. And in that context, you want to be as lean and mean as possible, as efficient as possible. Now, obviously, Java has already shown itself to be very, very energy efficient. It's routinely ranked among the top 5 most energy efficient languages out there, along with the likes of C and Rust and so on. That is to say, the energy that you spend when using Java per operation is much less than you would get in most other languages. So while Java may be energy efficient, it's still a very big piece of infrastructure, right? It takes a lot of RAM. That's okay. That's normal on the server side. But in the context of a client application running at the edge, perhaps, we can do better. So let's use GraalVM, right? We're going to create a native image using Spring Native. There are some hints that we're going to need to add to make this work. Spring integration already works pretty well out of the box in a native context, but the Eclipse PAHO MQTT client isn't yet GraalVM ready. But it wasn't hard. I got this trivial example, which does both production and consumption, working with just a very simple set of hints. Hopefully these won't always be required. I hope that they eventually ship with the MQTT project, the PAHO MQTT project, or with Spring Native, or not too far from now, somewhere in the Spring Boot world, Spring Boot 3 and Spring Framework 6 world. Hopefully it'll just ship as part of Spring integration, right? But okay, let's just see. We've got our hints. We've got the configuration for various patterns, for various resources. They get loaded. We've got the configuration for various types that we do reflection on. Well, that Eclipse Paho does reflection on. With that in place, we're ready to build a native image. So with that in place, we're ready to build a native image. Let's go to the build, and I'll do maven d skip test equals true clean package. And I want to run this in the native profile, the Maven profile called native. This will take, it'll take a minute probably. It takes a fair amount of time to create Graalvm native images. Obviously, if you want to learn more about this, you should definitely check out this video introducing all the bits behind Spring Native 011.x. All right, there's our build. It's finished. Let's go ahead and kick it off. So you can see it started in about 400 milliseconds, which is a long time for a native application. But bear in mind that there's a lot of network I/O that has to be done when the application starts up. Anecdotally, I found that when I do, for example, a Spring integration native application using just file system adapters, right? So local file system I/O, no network connectivity, no handshake, no whatever MQTT and HiveMQ are doing behind the scenes, that typically starts up in about 30 milliseconds. So it can be a lot faster depending on the kind of thing you're doing in your integration flow. It really is about 400 milliseconds. It just seems to be a permanent sort of fixture of using MQTT and HiveMQ together. I don't know what it is. Maybe it's the handshake, but it doesn't really all that much matter because, again, we're not creating a Spring integration flow for like Lambda or something, right? The startup time is not all that important. Don't get me wrong. 400 milliseconds is nothing to sneeze at. That's very fast compared to typically any other application. But it just feels a little disappointing when you're so accustomed to 20 or 30 millisecond startup times with your typical Spring integration application. What we care about is efficiency, right? That's where things get really interesting. Let's find the application. All right, there it is. It's running on PID 61010. I'm going to use Josh EMV bin RSS 61010. You can see it's taking 56 megs of RAM to run that integration flow and the embedded web server. Nice. All right, so good stuff. That's something you could easily deploy on any embedded context, right? My Apple Watch could run that. That's nothing, right? That's a very, very small piece of code computationally and in terms of footprint and so on. This makes it a natural fit along with MQTT in an embedded IoT sort of context. All right, good stuff, my friends. Thanks so much for watching. I hope you got something out of that. Thank you again to Mary for producing this video with me. It was a lot of fun working with you, my friend. I learned a ton, as always. And to the rest of you, I hope you got something. I hope this sparked some ideas, and I hope that you'll try it out. And as always, thanks for watching, and we'll see you next time.